At 11:34 p.m. last night, Dr. Eleanor Vasquez watched her computer screen in horror as radiation detectors across the International Space Station painted the worst reading she had ever seen. Red warning lights flooded the control room. Emergency alarms echoed through corridors as astronauts scrambled for shelter. The numbers climbing on her monitor were not from a solar flare or routine space weather. They were cosmic rays, the universe's deadliest ammunition, pouring through a gap in our solar system's defenses that should not exist. The breach had opened hours earlier when the sun's magnetic field completed its catastrophic reversal. Both poles now carried opposite charges, transforming our star's protective barrier into a twisted wreckage of conflicting forces. The heliospheric current sheet, normally a smooth electrical boundary stretching billions of miles through space, had become a chaotic storm of magnetic turbulence. Through the cracks, particles accelerated by dying stars were racing toward Earth at 99% the speed of light. GPS satellites began failing within minutes. Communication networks started dropping offline across 6 continents. But the cosmic ray bombardment will not stop at electronics in space. These universe-born projectiles penetrate deeper than any terrestrial radiation, threatening everything from airline passengers to nuclear reactor control systems. Scientists estimate the barrage could continue for months, possibly years, as our solar magnetic shield remains in ruins. So what happens when the most advanced technological civilization in human history faces an attack from the cosmos itself? How many more satellites will we lose before the radiation storm ends? And if our planet's magnetic field cannot deflect this bombardment alone, what other critical systems are already under assault? For billions of years, our sun has served as more than just a source of light and warmth. It has been Earth's invisible guardian against the most violent forces in the universe. The solar magnetic field extends far beyond the visible solar disk, creating a colossal bubble called the heliosphere that envelops our entire planetary neighborhood. This magnetic fortress stretches over 11 billion miles from the Sun, more than 3 times the distance to Neptune. At the center of this protection lies the heliospheric current sheet. It is a gargantuan electrical surface that spirals outward from the Sun's equator like a cosmic ballerina's tutu. This boundary carries an electrical current of 10 billion amperes, enough to power human civilization for millions of years. More critically, it acts as a deflector shield against galactic cosmic rays. Ultra-high energy particles accelerated to near the speed of light by supernova explosions thousands of light years away. According to Dr. Todd Hoeksema of Stanford University's Wilcox Solar Observatory, this change will have ripple effects throughout the solar system. The magnetic field does not just safeguard Earth, it protects every planet, moon, and spacecraft in our celestial backyard. Mars lost most of its atmosphere because it lacks this defense. Without our sun's magnetic barrier, Earth would face the same fate. But this shield is not eternal. Every 11 years, the sun's magnetic field undergoes a complete reversal as part of the solar cycle. The process usually unfolds gradually over months, allowing the protective barrier to maintain partial effectiveness even during transitions. Solar cycle 25, however, has shattered that predictable timeline. Historical records reveal a pattern of solar magnetic reversals stretching back centuries. Solar cycle 1 through solar cycle. Well, 24 followed predictable sequences, including gradual polar field weakening, months-long transition periods, and systematic reconstruction of magnetic defenses. Each reversal created temporary spikes in space weather, but the protective heliosphere remained fundamentally intact. The Wilcox Solar Observatory has monitored solar magnetic fields since 1975, recording 4 complete reversals with instruments that have never changed or been upgraded. That long-term consistency allowed scientists to develop mathematical models as predicting reversal timing with remarkable precision. Solar Cycle 24's reversal, completed in 2013, took nearly 5 years from initiation to completion. The extended timeline allowed the current sheet to maintain partial effectiveness throughout the transition. Space weather increased, but cosmic ray deflection continued at reduced but manageable levels. Solar Cycle 25 obliterated those expectations. The Northern Hemisphere reversal began early, completing in August 2024, months ahead of predictions. But instead of the gradual Southern Hemisphere transition expected through 2025, the Southern Pole collapsed rapidly in February 2025, creating synchronized magnetic mayhem. Dr. Bill Chadwick admits that nature does not have to conform to our predictions. The accelerated timeline compressed what should have been a 2-year gradual transition into a 6-month catastrophic collapse. No historical precedent exists for this type of synchronized magnetic failure. The speed of collapse left no time for technological adaptation. Satellites designed to weather gradual magnetic transitions suddenly found themselves exposed to cosmic radiation levels not seen since the formation of the solar system 4.6 billion years ago. February 7th, 2025, 11:47 p.m. Universal Time. Space weather monitoring stations worldwide detected something unprecedented: the simultaneous collapse of both solar magnetic poles into reverse polarity. Unlike previous solar cycles where hemispheric reversals occurred months apart, creating gradual transitions, both poles flipped within hours of each other. The Wilcox Solar Observatory recorded the southern hemisphere magnetic field strength plummeting from -12 Gauss to +8 Gauss in under 6 hours. Meanwhile, the already reversed northern hemisphere intensified its new polarity to +15 Gauss. This created a perfectly inverted dipole configuration with magnetic field lines that no longer shielded against cosmic rays. Real-time measurements from the Solar Dynamics Observatory showed the heliospheric current sheet immediately transforming from coherent waves into chaotic turbulence. Instead of the smooth electrical surface that had deflected cosmic rays for eons, space telescopes detected a fractured labyrinth of conflicting magnetic forces stretching throughout the solar system. The consequences struck Earth's orbit within minutes. The Deep Space Climate Observatory, positioned 1.5 million kilometers from Earth, registered cosmic ray flux surges of 340% above normal levels. This was not solar particle radiation. These were galactic cosmic rays, subatomic bullets accelerated by dying stars, and normally repelled by our solar magnetic shield. The bombardment began with humanity's most vulnerable assets, satellites operating beyond Earth's atmospheric protection. The GPS constellation, consisting of 31 active satellites, experienced cascading failures starting at 12:23 a.m. Universal Time. Signal accuracy degraded from meter-level precision to kilometer-level uncertainty, as cosmic rays damaged sensitive timing electronics. Communication satellites proved equally susceptible. Intelsat reported 7 satellites entering emergency safe mode as cosmic ray impacts triggered system-wide malfunctions. The European Space Agency's Galileo navigation system suffered similar degradation, with 4 satellites completely offline by dawn. But the threat extends far beyond space-based infrastructure. Commercial and aviation confronts unprecedented radiation exposure as cosmic rays pierce aircraft at cruising altitudes. The Federal Aviation Administration issued emergency directives requiring polar route diversions and ray pump mines, and radiation monitoring for all flights above 35,000 feet. Nuclear facilities across 6 countries reported increasing sensor anomalies as cosmic rays interfere with radiation detection systems. The similarity between cosmic ray signatures and radioactive decay products creates false alarms that could trigger emergency shutdowns. At Fukushima's monitoring stations, cosmic ray strikes are producing readings that mimic radioactive contamination. even ground-based electronics display vulnerability to the most energetic cosmic ray particles. Power grid sensors in northern Canada detected unexplained electrical surges consistent with cosmic ray impacts on semiconductor components. Bank transaction processing centers in Iceland experienced intermittent failures as high-energy particles penetrated data storage systems. The European Organization for Nuclear Research temporarily suspended Large Hadron Collider operations after cosmic ray interference corrupted experimental data. When the world's most sophisticated particle physics facility cannot distinguish between cosmic rays and controlled particle beams, the scope of technological vulnerability becomes starkly clear. NASA estimates the cosmic ray bombardment could persist for from 18 to 36 months, depending on how rapidly the Sun's magnetic field stabilizes. During this period, every electronic system above Earth's atmosphere confronts escalating destruction from universe-born radiation that our solar system has never before endured. When cosmic rays strike satellite electronics, they don't merely damage circuits, they rewrite the fundamental laws governing space-based technology. These universe-spawned particles carry energies millions of times greater than terrestrial radiation, capable of flipping individual bits in computer memory, corrupting software, and permanently degrading semiconductor materials. The assault follows a predictable pattern of escalating destruction. First, satellites lose GPS timing accuracy as cosmic rays damage atomic clock circuits. Navigation errors cascade through dependent systems. Aircraft drift off course. Ships lose positioning, and precision-guided weapons become unreliable. Financial networks that depend on GPS timestamps for transaction verification experience systematic failures. Next, communication satellites suffer cascade failures as cosmic rays corrupt onboard software and damage power systems. The internet backbone that connects continents through satellite uplinks begins fragmenting. Undersea cables designed as backup systems strain under the surge of traffic as satellite capacity vanishes. International commerce grinds to a halt as real-time financial communications become impossible. The final phase targets Earth's most critical space-based assets: weather monitoring and early warning systems, meteorological satellites that track hurricanes, monitor climate change and provide essential forecasts, experience accelerating degradation. Military satellites designed to detect missile launches produce increasing false alarms as cosmic rays trigger sensor anomalies. By the 6th month of the cosmic ray bombardment, space-based civilization effectively ceases to function. The multi-billion-dollar satellite industry collapses as replacement launches cannot match the pace of cosmic ray destruction. Human civilization, built upon a foundation of satellite-enabled technologies, faces an existential reckoning as it confronts the true fragility of its cosmic neighborhood. But the threat does not end at the edge of space. The most energetic cosmic rays punch through Earth's atmosphere, reaching aircraft cruising altitudes and eventually the surface itself. The approaching storm of invisible radiation will reshape every aspect of life on Earth, from aviation to power grids to nuclear safety systems. And with each passing day, the technological shields we once trusted to protect us grow increasingly brittle. The collapse of our sun's magnetic field has transformed Earth from a sheltered oasis to a world directly exposed to the most violent forces of the universe. The question now is not whether our technology can withstand the cosmic onslaught, but whether our civilization can adapt to a reality where the infrastructure we have come to depend on no longer functions as designed. The cosmic storm of the century is no longer approaching, it is already here, and the waves that have already struck our planet are just the leading edge of a radiation tsunami that will reshape our relationship with technology, space, and the cosmos itself. Our sun's magnetic shield has collapsed, leaving Earth defenseless against cosmic forces that could destroy our technological civilization. Satellites are failing. Aircraft face dangerous radiation. Ground systems show vulnerability to particles from space. What happens when the cosmos attacks our connected world? How many critical systems will cosmic rays destroy before our solar protection rebuilds? Drop your thoughts below and subscribe, because this bombardment is just beginning.